Okay, let's have a look at the pirate question. And what's the pirate question asking you to do? It's asking you to find an nth term for finding the angle. So let's get a few straightforward things out of the way. First, you'll notice that I've used this symbol here for the angles. I've used these. And this is the Greek symbol theta. And we traditionally use the theta because the Greeks did an awful lot of geometry. So we're looking for an nth term for finding the angle. So let's have a look. Let's have a look at that first triangle. The first triangle, to find the angle, we could use some trigonometry because we've got an opposite, we've got an adjacent, which means we can use the tangent function. So the tan of theta 1 is the opposite divided by the adjacent, which is 1 divided by 1, which is 1. So the angle is found by using that as my formula. That's going to cause me a little bit of problems in a moment, and you'll see why. So let's go and have a look at this one. Well, for the next one, my next problem is I don't have this length. I do have the opposite. So can I get that length? This length is my adjacent. If I go back to my original question, this adjacent here is the same as the hypotenuse for the first triangle. So for the first triangle, if I want to work out this is what I'm going to do. I'm going to use Pythagoras. 1 squared plus 1 squared is 2. So this line here, so my side, my hypotenuse, is the square root of 2. So this is the square root of 2. And I'm going to keep it in third form because it's easier. So let's have a look at this one. So if we go back to, if we look at this one again, the tan of theta 2, because again we've got an opposite and adjacent, is going to be 1 divided by root 2. So the angle is the opposite of that. What's the inverse of that? That's the angle. So that's what I'm going to press into my calculator to find the angle. Okay. Doesn't look massively like that. But if I left this in this form, it does have a similarity. Still not the same though. There might be something I can do. I'll have a think about that. So I've got an opposite, an adjacent, and that adjacent, if we remember rightly, will match that hypotenuse there. So that hypotenuse there is gained by 1 squared plus the square root of 2 all squared, and then we square root the answer. So that's going to give me 1. 1 squared is 1, square root of 2 squared is 2. This is going to be the square root of 3. There's the square root of 3. Okay, so here, how are these linked? Well, tan theta 3 is the opposite divided by the adjacent. These look very, very similar patterns. Let's look at what we know that's similar. Well, second triangle, theta 2, there's a 2 there. Theta 3, there's a 3 there. That's looking good. Let's go back to this first one. Go back to this first one. Let's have a little think. Tan theta 1 is 1 over 1. It's also 1 over the square root of 1. What's the square root of 1? Oh, that would be 1. So I could change my formula and that would also be true. It would give me exactly the same answer as that. And now I've got a thing where, if I look for a general formula, my tan theta n is going to be, my opposites are always 1. And if we look at those adjacents, they're always the square root of the number of the angle. So my angle is this formula here. My angle is the reverse tan, I know the tangent function. I've shoved that into my calculator and said, could you tell me what the angle is? And it's always the square root of the number of the theta. So that should have an n there. Tell me it's theta number n. That's my nth term. It is cunning. It is quite a hard idea. And I would expect one or two members of the sixth form to have to stop and think to do this. So I'm not saying it's super easy. So if you have got there, that's brilliant. If you can follow my argument, even if you didn't reach there, that really is very good too. And if you're thinking this is totally confusing, remember you are a year 9, you are allowed not to do the pirate questions. Thank you.